This video contains flashing blue and white lights during the 3D scanning process, which may not be suitable for viewers with photosensitive epilepsy. Viewer discretion is advised. Hey everyone, and welcome back to Hoffman Engineering. Today we are taking a look at the Moose 3D scanner by 3DMakerpro.
I look like a moose.
Yes, but a very cute moose. Make all the boy moose go, wah!
This handheld scanner is designed for high-detailed scans of medium-sized objects, think palm-sized and larger. It uses a blue light scanning technology that claims to leverage AI for marker-free scanning. But does that result in an awesome 3D scanner for both hobbyists and professionals? Let's find out. Before we begin, this Moose 3D scanner was sent to me for review by 3DMakerpro. As with all of my reviews, they aren't paying me for this review, and everything I say is my own honest opinion after using this scanner for the last month. My videos do have affiliate links in the description, so if you're interested in anything you see in my videos, you can use those links to help support my channel. Now let's get into it. The Moose 3D scanner is 3DMakerpro's latest handheld 3D scanner. It is a structured light scanner, which uses quick pulses of visible blue light to shine a pattern onto the object you are scanning. The camera then detects how that pattern deforms over the surface, which it can calculate depth information from. Blue light scanners tend to be more accurate, as the shorter wavelength light helps the surface accuracy, as well as normally working better on darker surfaces that give many structured light scanners problems. We'll get back to that in a minute though. I have to note here that 3DMakerpro has another scanner called the Moose Lite, and that scanner uses a completely different scanning technology. This review is for the Moose, not the Moose Lite. Looking at the front of the scanner, we see the depth sensor on the left, the colored sensor and 4 white LEDs in the middle, and the blue light projector on the right. The blue light pulses during scanning. It only shines for a fraction of a second. When running in texture mode, the white LEDs and color sensors kick in. The white LEDs also pulse like the blue light, around 10 to 12 pulses per second. That pulsing can be disorienting if you look at it, and if you are photosensitive, this would not be the scanner for you. The color sensor is used to create a full color texture map of the scanned object. The textures are very detailed, and the colors are vivid. This might be the best looking texture map that I've seen on a handheld scanner. The only other features on this scanner is the USB Type-C port for power and data on the back, and a 1/4-20 thread on the bottom for the included tripod stand. The Moose scanner is lightweight and portable, easy to hold and move around while scanning. There are no buttons to adjust any settings, or to stop and start the scan on the scanner itself, so you'll need to do all of that on the computer that you are connected to. The Moose comes in a nice hard carrying case with a zipper. Opening it up, we see the included cables, the top of the turntable, and the instruction manual. On the bottom, we see the wall power plug, the extending tripod, the turntable base, and the Moose scanner itself. The case will keep the scanner well protected and is easy to carry around. The Moose 3D scanner uses JMStudio, a free software that other 3DMakerpro scanners use. As I discussed in my previous video about the Mole scanner, I like JMStudio. The initial launch page does make it seem like you need an account to use the software, but thankfully there is a guest mode that you can click on to continue without an account. From the main page, you can start a new scan or continue to edit an existing file. When starting a new scan, you decide between Easy Scan or Turntable Scan. If you are using a turntable, you can then calibrate the scan with the empty turntable first. Then, after you scan, JMStudio will automatically detect which parts of the scan was the turntable and select those points for deletion. That saves you a step when cleaning up the scan. The other mode, Easy Scan, is for your normal handheld scanning. The scanning workflow with the Moose is pretty simple. Place whatever you want to scan in front of you, then select either geometry or texture mode. Geometry mode will capture just the scan data, but will not create a texture map. If you want color, then you'll want to select texture mode. On the right side is a histogram that lets you know if you are too close, too far, or just the right distance away from the object. Finally, adjusting the brightness and sensitivity until all the red in the preview goes away. Then you can start scanning. As you move the scanner around the object, you can see the point cloud captured in JMStudio. In turntable mode, it'll automatically stop after one rotation of the turntable. In Easy Scan mode, you can continue scanning as much as you want until you press the button to stop. The Moose scanner scans at 10 frames per second. While this isn't the highest frame rate, it does give a smooth experience. JMStudio does a good job with tracking, but if you move too quickly, sometimes it will lose tracking. It'll let you know when, and prompt you to return to a previously scanned area where it will resume. When you are done with a scan, JMStudio has plenty of tools to help you clean up the scan and remove unneeded parts. The Moose scanner can only capture what it sees, so often you'll need to do multiple scans at different angles to capture all the details. JMStudio will then try to automatically align them. Most of the time, the auto alignment works, but sometimes you'll need to manually align them by selecting common points on the two scans. After aligning, then comes the final step of processing the scan. Here it will fuse the point cloud into a solid mesh and try to close any holes or gaps if you've selected those options. Finally, if you are scanning in texture mode, it'll create the full color texture map. And there you have it, a completed 3D scan. You can export the scan as a .obj, .stl, or .ply, very common file types that most 3D software can work with. I found that the Moose 3D scanner has more of a learning curve than other 3D scanners that I've used. I had to practice and get to know the scanner before I started getting consistent results. The Moose scanner has a relatively narrow range where it picks up data. The JMStudio doesn't explicitly state it, but I think that the histogram on the left is millimeters, and implies that there's less than a 100 millimeter range of distances where it's in the ideal location. This is compared to the 200 millimeter range difference of the mole scanner which I tested previously. The scan area also seems smaller, like the Moose captures a smaller patch of an object on each frame. This makes it easier to lose tracking by moving too quickly or going out of the ideal range, until you get to know where the scanner wants to be. By the end of my tests, I was getting very consistent results, and I could feel myself becoming more familiar with how the Moose scanner works. So let's take a look at some of my scans. This Ryobi drill scanned really well in texture mode. I was able to find the brightness setting that captured the black chuck without blowing out the bright yellow color. 2 separate scans were needed to capture all the angles, and JMStudio's auto alignment worked wonders. A bit of cleanup later and we can process the scan, which took 3 minutes and 30 seconds to complete. At a glance, the scan turned out great. It didn't capture the entire length of the reflective metal drill bits, but the rest of the drill and battery looked very detailed. Turning off the textures for a moment lets us look at the mesh quality. The holes and vents around the body are all present, and there's no obvious missing areas. We can see that some of the flat text on the labels were transferred onto the mesh itself, giving a sort of embossed effect. But that effect is present on many other scanners that I've tested. Turning back on the texture mapping, we can see that those labels are generally pretty high detailed. I found the bottom of the battery very impressive. The bottom text is perfectly legible. The Moose scanner claims to have a 0.03mm accuracy, with scans exporting the real-world dimensions without a need for an additional measuring and scaling. So, using the drill example, I used my calipers to measure 6 different areas, and compared them to the exported scan measured in MeshMixer. I was very impressed. For the plastic body, the Moose scanner was consistently within half of a millimeter of the actual measurement, less than a 0.5% difference. The scan model was just slightly undersized. The accuracy was worse on the darker plastic, with the black chuck measuring 1.03mm smaller than the actual diameter, or a 2.4% difference. And unsurprisingly, the reflective metal drill bit was very inaccurate, off by 1.5mm or a 29.1% difference. I don't have the metrology experience to be able to really categorize the accuracy of the Moose scanner, but to be off by 0.5% without any calibration would be more than suitable for the projects that I do as a hobbyist. So let's shift to something more decorative. This Vault Boy has bright colors as well as dark shoes and eyes that have given other scanners problems in my past testing. Here, JMStudio's auto alignment failed. It tried to align the scans facing the wrong direction. Manual alignment worked great though. The final results were pretty good. The overall texture mapping is almost flawless, with the eyes, face, and hair looking identical to the real objects. The only fault was with the shoes. There is a small chunk missing from one of them. Some colors and materials do cause problems for the Moose scanner. This 3D printed skull is a scanner's worst nightmare. Many extremely small holes, and it's printed out of a slightly transparent jade filament. Unsurprisingly, the blue light scanner of the Moose simply could not capture it, no matter the brightness or sensitivity setting. This figurine was one of the messier scans, and I didn't clean up any of the extra points before processing. JMStudio did an excellent job with processing the model, and it was able to handle all that extra data. Even after processing, you can use the selection tools to select parts of the final model that you'd want to modify or delete. This Voronoi Bulbasaur is another very difficult object to scan. The thin tubes occlude each other, making it almost impossible to scan the inside and the outside without leaving gaps and holes. Auto alignment wasn't perfect, but manual alignment was easy enough. Historically, JMStudio hasn't fared well with this model, and, well, the Moose scanner didn't make it work any better. It still filled in almost the entirety of the inside, thinking that the missing points should have all been connected. This 3D printed dragon has been a staple of my scanner tests. The Moose 3D scanner did a decent job at capturing the form, however I found that the scanning process was more difficult than usual. Having to keep the Moose scanner at just the right distance was tough when this model was on the turntable, because sometimes I wanted to scan the front of the wings, and sometimes I wanted to scan the back, and trying to capture both would almost always result in losing tracking. Eventually I did get a complete scan though. The resulting mesh has some problem areas, the edge of the wings and between the arms specifically. However, the rest of the face and the body were captured very accurately. Reflective objects need special surface treatments. This lion statue has a shiny gold surface and reflective mirrors that could give scanners a hard time. Many of the scanners that I previously tested were able to capture the main body, but they would miss out on the highly reflective areas. The Moose scanner was unable to scan any part of the lion without a surface treatment. Only after I used dry shampoo to lightly coat the surface with a matte powder was the Moose able to complete a scan. Transparent objects would also need the same surface treatment. This Stadia controller was pretty easy to scan. It captured both the white body and the black buttons and triggers without issues. I exported the model and imported it into my 3D printing slicer, where I gave it a quick manual coloring, because my slicer doesn't support the texture maps. I then printed it on my multicolored Anycubic Cobra 3 printer. 13 hours later, I removed it from my printer, removed the support material, and now I have a copy of the Stadia controller. The sizing is spot on, and I did no manual scaling or adjustments. This is the model directly out of JMStudio. So let's give one more technical test, a pure black PS4 controller. I had to increase the brightness in order to scan it, but we ended up with this scan. The moose did an excellent job with this black object. There are slight texture misalignments visible on the buttons, but looking at the underlying mesh, we see that the thumbsticks are accurately represented and the mesh quality is great. So finally, let's move on to face scanning. There is a reason that none of the moose's marketing focuses on face scanning. The flashing blue and white lights are extremely bright and very uncomfortable. You wouldn't actually want to scan someone's face with the moose scanner, but of course I did it anyways for you all. The main thing to notice is that I could not find a brightness setting that captured both my skin and my hair, so my hair was missing from the scan data. After processing, we see that it filled in the gaps where the beard is. When we apply the texture mapping, we see a very high resolution texture applied. I would not recommend the Moose 3D scanner for faces, but the rest of the body would be scannable with the Moose. So in conclusion, the Moose Scanner by 3DMaker Pro is a capable handheld scanner with a steeper learning curve. It fits the bill for scanning medium-sized objects, and creates models with decent, if slightly undersized, dimensional accuracy. It did a good job at scanning black objects, but the use of surface sprays like dry shampoo or foot powder is a must for any slightly reflective or transparent objects. It took some practice to learn the size and shape of the moose's scanning area, and how to move the scanner to get decent results. Eventually it clicked and I was getting good results, but it took a number of scans to get there. The software program JMStudio felt the same as it has in my other 3DMaker Pro scanner reviews. It has a few rough edges, and there are some situations with missing data that could trip it up, but ultimately the workflow is pretty straightforward and easy to go from initial scan to final model. 3DMaker Pro definitely jumped onto the AI hype with their branding, but I don't believe an AI-powered scanner is an accurate description. It's simply markerless tracking technology that has been present in 3DMaker Pro scanners for many years. But if you look past the hype, and you don't mind a bit of practice, then the Moose scanner could be the medium format scanner that you're looking for. The Moose scanner sells for $699 US at the time of recording. That places it in the middle of the market for handheld scanners, and is a price point that I think I agree with. The Moose is more capable than many entry-level handheld scanners from 3DMaker Pro or competitors like Creality or RevaPoint, but it doesn't quite match the quality of more expensive scanners like the Creality Otter or Raptor. So thank you all for watching my review of the 3DMaker Pro Moose scanner. What is your favorite feature of the Moose? What features do you think it's missing? Let me know in the comments below. And be sure to subscribe to Hoffman Engineering so you don't miss out on any of my upcoming 3D scanner reviews. If you are still in the market for a 3D scanner, why not check out my review of the Creality Otter scanner? It might just be the scanner you were looking for. So thank you all for watching, and I'll see you all next time.